To demonstrate one of the fundamental ideas of catalysis, we're going to use this plastic tubing and some small fun balls that will fit exactly into the tubing to try and show one of the ideas of catalysis, that a barrier can be lowered in the presence of a catalyst. To explain the background to this, we're just going to go through some basic theory first. A hydrocarbon contains largely carbon and hydrogen, and one of the main things that we do with hydrocarbons is to burn them, to use them as fuels, both in heating and in cars as petrol to drive automobiles. This involves combining the carbon and hydrogen with oxygen, which is O2, and we take the carbon and oxygen and make carbon dioxide, CO2, and the hydrogen converts to water. This is really the ideal situation for what's called a combustion reaction, and I've drawn the molecules in a particular way so that I can think about the energies involved as involving lowering the energy of the hydrocarbon and the oxygen to make the CO2 and water. And it's this lowering of energy which gives us the power that we use in our automobiles or in giving us heat to heat our homes. Now, hydrocarbons usually can exist in an atmosphere without spontaneously converting to CO2 and water, and the way we think about this is to imagine that there's an energetic barrier that the molecules must go over in order to have the transformation take place. And the higher that barrier is, the more difficult it is for the reaction to take place. And in the case of the hydrocarbons, we require high temperatures before we can get spontaneous combustion. Now, when we do combustion where there's a limited amount of oxygen present, we can easily produce carbon monoxide. So carbon with only one oxygen attached. And this is actually a poison to the human body, and so we really need to eliminate it from any environment in which we need to be. And the way we do this is to use a catalyst, because there's a similar barrier to taking the CO to CO2 as there is for the hydrocarbon to go to CO2. What the catalyst does is it consists of a particle of metal, and we're beginning to think that gold is a particularly good metal to use as a catalyst for this reaction. And what happens is the CO can absorb on the gold particle, the oxygen can absorb on the gold particle, and that process itself has a small barrier, but much smaller than the combustion barrier. And then from that position they combine together to make CO2, and we end up with a product that we like. Now you notice that I've drawn the barriers for these two steps in the reaction as a lot lower, and that's the job of the catalyst, is to lower the barrier from a very high barrier that would be needed a lot of high temperature motion of the molecules to get over at normal conditions, but with a catalyst present those barriers are a lot lower, and so the reaction will proceed at much milder conditions. Now what we'd like to do in our demonstration at the Royal Society is show people a pathway like this, but in quite an interactive way. And so what we've tried to develop is a way of representing the molecules as small balls and the pathways that they have to go over as a trackway in a tube. Now what we've worked out is that we need about 3 bars of pressure to get this ball to move, and we store the compressed gas in the tank. So what will happen in the display is that people from the audience will do my job of using the pump, and they'll get the pressure stored. So we're up at pressure now, and we should be ready to go. This entire reservoir is up at about 3 bar. You can follow the pipe up, and the pressure being held at a valve is release that pressure, and just watch what happens to the ball. So the ball's in place, release the pressure, it's gone. We can follow the pipe up the stairs, see how far we've managed to shoot it. And you can see it's gone all the way up through the piping up to the top of our barrier, round here, and it's got down to this position in the tube. So I think we're going to be able to make this demonstration work and have something interactive for people to play with when they come and visit us at the Royal Society in London.